Linear Algebra 101, Section 1.7, Products of two two-dimensional vectors. What are the possible products of two vectors in 2D space? How many can you come up with the products? We may multiply two scalars or integers together, for example. So we may also multiply two vectors or any objects together. However, we encounter some difficulty for the idea at this point. Why? Why is it that it is very tough to define the product? It is easier to approach this issue at hand from algebraic perspective. Question: how many ways can we form the multiplication of two products, two vectors u and v, where u equals av, v equals cd, enclosed by a pair of square brackets? Think about how many combinations of multiplication and addition of the components of the two vectors there are between u and v. Traditionally, mathematicians define the following three products of two vectors on 2D space: inner product, cross product, outer product, or dot product, scalar product, vector product, and tensor product. Inner product of two vectors may come up by randomly multiply the two aligned components together in a play of vector components. As you can see, later on we will form the inner product for you. Inner product of two vectors takes two vectors and produces a scalar or number that's going from 2D space to 1D inner-based space. Hence, the name inner product. Inner product of two vectors in vector component form. U inner product V equals AC times BD. The first component times the first component, and the second component times the second component of the vectors. And the outer product of two vectors, aka tensor product, in vector form is AC, AD as the first row of the matrix, BC, BD as the second row of the matrix. The cross product of two vectors, U cross dot product V, is from two-dimensional to a three-dimensional vector with AD minus BC as the third component of the vector coordinates. Determinant product of two vectors in vector component form is AD minus BC. Remember, it's like a cross product, a third component placed here. Complex number product for two vectors. It's the first element is AC minus BD, the second is AD plus BC. It's very interesting because it's like A plus BI times C plus DI. Eureka! This is your lucky day. How many products of two vectors are possible? An algebraic approach was presented here. There are five different products we have covered in this presentation: inner product, outer product, cross product, determinant product, complex product, or complex number products. There are so many permutations and combinations we may produce the products of two 2D vectors. Would you create more well-defined products of two vectors? It's easier to use algebra to define these products. Are you with me or without me? Go.